paying attention to this object that's hurtling towards Earth? It's called A30. They're calling it A31.
I try to avoid things that are going to give me nightmares. Are we going to send? Are we going to
extraterrestrial? Perhaps.
Is it really? We're going to meet the aliens finally?
There's something weird about it. We were just going over it the other day. There was an article that was stating that whatever they use to detect, like what is around this, like they can detect the composition, whether it's like mostly water, vapor, mostly iron. This thing is giving off the indications that is an alloy that only exists on Earth through industrial alloy making processes.
Okay.
That it's not a natural metal.
Okay.
And that's what they're getting is the signal that this thing that is hurling through space, this massive object that's moving, by the way, from the same direction in space where the WOW signal came.
Mystery interstellar object that was spotted by astronomers last week. It could be the oldest comet ever seen. It's only the third time that we've...
Scientists across the world are in shock because something has entered our solar system that doesn't just bend the laws of physics. It completely ignores them. This mysterious traveler, known as Threeey Atlas, is doing things that should be impossible. It's firing beams of light directly toward the sun, shifting its colors like a cosmic mood ring, and tracing a flight path so deliberate it feels engineered, not random. Some Harvard astronomers are quietly whispering what everyone else is too afraid to say. This could be artificial. But here's the question no one wants to ask. If Threeey Atlas can aim with pinpoint accuracy at Mars, what happens when it decides to turn toward Earth? Right now, something is moving through our solar system that has astronomers completely baffled. They've named it Threeey Atlas, but that's about the only thing that makes sense. From the moment it appeared, this object has refused to behave like anything we've ever seen in the history of space observation. At first, it looked like just another harmless rock from deep space, a frozen chunk of ice and dust wandering on a predictable path. But as scientists began to study it, they realized this thing wasn't playing by any of the usual rules. Threeey Atlas began to rewrite the script of what we thought we knew about cosmic visitors. It pulled off maneuvers that made even the most experienced astronomers stare at their instruments in disbelief, wondering if their data had somehow glitched. Its brightness didn't behave normally. Instead of gradually changing over time like every comet before it, Threeey Atlas would suddenly flare to life, exploding from near invisible to blindingly bright overnight, then fade again without warning. These weren't subtle changes spread over weeks or months. They were dramatic, violent transformations happening in hours. Veteran scientists who had spent decades studying predictable space patterns suddenly found themselves questioning everything they knew. And the strangest part? The light wasn't coming from gas or dust around it, the usual coma that gives comets their fuzzy glow. No. Threeey Atlas was shining from its surface directly, as if something on it was producing light intentionally. Imagine finding a snowball drifting in space that somehow powers its own lighting system. That's how bizarre this is. When respected researchers, people who've spent their entire lives debunking conspiracy theories, start suggesting that maybe, just maybe, this thing isn't natural. You know, something extraordinary is happening out there. Every space rock we've ever studied obeys the same simple rules. They heat up near the sun, shed gas and dust, and form a predictable glowing tail that always points away from solar radiation. Their brightness follows neat mathematical curves we can chart months in advance. But Threeey Atlas looked at those expectations and decided to break every one of them. Its first act of rebellion? A complete color shift. As it neared Mars, it transformed from deep red to electric green, almost instantly. That shouldn't be possible. For normal comets, color changes happen slowly, caused by chemical reactions as sunlight heats different materials layer by layer. But Threeey Atlas didn't follow that timeline. It changed colors too quickly at the wrong distance under the wrong conditions, and then things got even weirder. As it passed through the asteroid belt, its brightness surged again, violently, unpredictably, in ways no heating model or chemical formula could explain. Normal comets follow smooth mathematical brightening curves. Scientists can predict their glow with astonishing accuracy. Threeey Atlas ignored those equations completely. It acted like a rebel object rewriting the cosmic playbook, a silent, glowing messenger from somewhere far beyond our understanding. Threeey Atlas isn't following anyone's timetable. It seems to run on its own inner clock, indifferent to the sun's pull, to gravity itself, and to every pattern the universe has taught us to expect. Its brightness flares at random, drawing a jagged light curve that looks less like a cosmic record and more like a stock market panic rendered in starlight. For centuries, comets have behaved with predictable rhythm. This one laughs at order. The most unsettling thing about Threeey Atlas is its light, a spectacle that violates the oldest laws of celestial behavior. It emits a focused ray aimed straight at the sun, something as nonsensical as water rushing uphill or frost burning at 1,000 degrees. Every comet we have ever cataloged grows a tail pushed away from the sun by radiation pressure, a simple, elegant rule of cosmic mechanics. Atlas looked at 4 billion years of precedent and decided to do the opposite. Through Hubble's unblinking eye, astronomers can see a luminous shaft stretching 10 times longer toward the sun than in any other direction, a cosmic lighthouse burning directly into daylight. No algorithm is needed to detect it. Anyone can see the violation plain as day. It is a bold defiance of every basic principle students learn in their first astronomy lecture. Scientists tried at first to rescue reason. Maybe, they said, enormous chunks of rock were breaking loose on the sun-facing side, reflecting light forward instead of back. Yet for that theory to hold, those fragments would have to be denser than iron and somehow immune to the solar wind that should shove them backward at thousands of kilometers per second. Instead, they appear to float calmly in front of the object, reflecting sunlight in ways no material has ever been known to manage. That single contradiction has split the scientific community. If those luminous fragments truly exist, then Threeey Atlas must be made of something far more solid and stable than the dirty snowballs comets are supposed to be. The beam's focus and unwavering shape suggest a deliberate mechanism, a system designed to sustain a coherent shaft of light across astronomical distances. Nature scatters light. Technology directs it. Atlas's forward-pointing glow behaves less like reflected sunshine and more like a controlled projection, a flashlight built for the void. If the physics of Atlas is rebellious, its chemistry borders on madness. The elemental makeup reads like the result of a cosmic experiment conducted by someone who misplaced the periodic table. Spectroscopic scans revealed a cocktail of 87% carbon dioxide, 9% carbon monoxide, and a meager 4% water, the molecular equivalent of discovering a fish made from feathers and stone. Ordinary comets are frozen time capsules of water ice, rock, and dust, fragile clusters earning the nickname dirty snowballs. Finding one composed almost entirely of carbon dioxide with barely any water is like digging up an iceberg made of glass and sand. The numbers don't just break the rules, they erase the rule book. The James Webb Space Telescope confirmed the insanity. Alongside the carbon gases were traces of nickel, but no iron. A cosmic divorce that shouldn't be possible. In every star system we've ever studied, those two metals are born together. Twin siblings forged in the same stellar furnaces, inseparable under known physics. Discovering nickel without iron is like finding one half of a DNA strand still functioning in isolation. It implies that Threeey Atlas either formed in an environment entirely foreign to our solar system or was assembled from materials crafted somewhere, or by someone else. The carbon monoxide only deepens the paradox. On its own, the molecule is common, but in this particular combination, abundant CO alongside massive CO2 and isolated nickel, the pattern matches nothing ever recorded in planetary science. Every chemical reaction we know refuses to produce this ratio under natural conditions. To chemists, it's as if the universe briefly forgot how to write its own formulas. When Harvard astrophysicist Avi Loeb speaks, the global scientific community listens, sometimes uneasily. Loeb built his career asking the questions colleagues whisper about but never print. His analysis of Threeey Atlas does the same. He suggests it might not be a comet at all, but a technological construct, a vehicle, maybe even a mothership. Loeb's idea isn't fantasy pulled from pulp novels. It's a structured theory built from data. The object's sudden bursts of brightness, he argues, could mark deliberate releases of smaller units. Reconnaissance craft dispersing into space, just as human spacecraft deploy satellites or landers. The timing of each flare aligns suspiciously with its approach to Mars, as though the object were conducting surveys rather than suffering chemical spasms. Patterns in nature are messy. These bursts were punctual, almost rehearsed. The precision is what unsettles other astronomers the most. To dismiss it as coincidence would require accepting odds so extreme they collapse into absurdity. And yet the notion that something is directing Atlas opens an even stranger door, one that science has always kept shut until evidence kicks it open. Loeb frames the hypothesis carefully. If the forward-facing beam acts as propulsion or communication, if the chemistry hints at engineered alloys, then every so-called anomaly fits into a single narrative, one of design. Even the presence of a potential companion object, C2025 R2 Swan, strengthens that possibility. Early orbital projections showed Swan moving from the same region of space, perhaps a detached fragment or dispatched probe. If true, Atlas isn't a visitor by accident. It's conducting operations. Of all its mysteries, the path of Threeey Atlas may be the most unsettling. Its trajectory is so mathematically precise that seasoned astronomers compare it to threading a needle while blindfolded from millions of miles away. The object glides almost perfectly within the ecliptic plane, the flat sheet where all our planets orbit, maintaining an alignment that natural interstellar visitors virtually never achieve. Most wanderers from deep space arrive at chaotic angles, tugged by random gravity wells and ancient collisions. Atlas, by contrast, seems to know where it's going. Its navigation looks deliberate, as if guided by computation rather than coincidence. Every correction in its motion feels strategic, not accidental. Even more curious is how it interacts with the planets. The object swings close enough to Mars to allow intimate observation, yet keeps a cautious, mathematically safe distance from Earth, near enough to intrigue us, far enough to avoid panic or interference. The spacing resembles mission planning, not random drift. Natural comets don't choose routes that balance curiosity and caution. Pilots do. Statistical models collapse under the weight of this precision. The probability of a random interstellar body naturally tracing such a smooth, planar orbit is so microscopic that the numbers lose meaning. For scientists accustomed to cause and effect, Atlas behaves like a taunt, a demonstration that someone else, somewhere, understands orbital mechanics better than we do, and the choreography doesn't stop with direction. Timing matters too. When Threeey Atlas reaches its closest pass to the Sun, the point astronomers call perihelion, it will slide exactly behind the star from Earth's viewpoint, vanishing completely from our instruments. Every telescope, ground-based or orbital, will stare into blinding daylight, while Atlas hides in plain sight. The alignment is so perfect it feels intentional, like a curtain drop at the end of a cosmic performance. The end of a cosmic performance. At this stage, even the most conservative researchers admit unease. The equations balance only if you ignore the evidence. The evidence makes sense only if you abandon the equations. A forward-pointing beam that shouldn't exist. Chemistry that reads like parity. Navigation that behaves like a flight plan. Each anomaly could be dismissed in isolation, but together they build a case too coherent to shrug off. Attempts to normalize Atlas's behavior now sound almost superstitious. New definitions invented just to preserve the illusion of control. It's as if science itself has reached the edge of its vocabulary. For 4 billion years, comets have obeyed the same choreography. Then, one arrives that dances to its own rhythm and refuses to explain the steps. If Atlas is a natural body, then physics needs rewriting from the atomic level upward. We would have to account for materials that form under unrecorded pressures, chemical reactions that shouldn't occur, and radiation behavior that contradicts electromagnetism itself. But if it is artificial, a creation of intelligence, then humanity has already witnessed technology far beyond its reach. Even skeptics find themselves using words they once mocked: craft, design, signal. The debate has become less about belief and more about evidence versus comfort. Observatories keep watching, data keeps breaking expectations, and the sky keeps offering no reassurance. Perhaps the strangest realization isn't that something might be out there, but that it might already understand us. The beam directed toward the Sun could be calibration or camouflage. The chemical oddities might be byproducts of propulsion, not composition. The precision of its orbit could mean it's mapping gravitational fields with accuracy beyond our instruments. Whatever the motive, the message is unmistakable. The universe is no longer a one-way mirror. We are not just observers of the cosmos. We may have become its subject of observation. When the day of its solar concealment arrives and Threeey Atlas slips behind the Sun, every radio dish and optical sensor will strain for a whisper. Maybe nothing will happen. Or maybe when it re-emerges, the patterns of light will speak, not in words, but in mathematics older than any human language. Until then, scientists wait, half terrified, half thrilled. staring at the coordinates where the impossible lives. Threeey Atlas continues its quiet defiance, carving geometry through emptiness, rewriting chemistry, mocking gravity, and shining a beam where no comet dares. And somewhere behind the brilliance, a question burns brighter than the sun itself. What if this was never a comet at all? The moment of truth is nearly here. As Threeey Atlas swings behind the sun, the torrent of electromagnetic radiation pouring from our star will blind every telescope and sensor pointed its way. For a short but critical window, the sun itself becomes a shield, concealing whatever this object may be doing while bathed in the most intense energy source in the solar system. What happens in that glare remains hidden, and possibly transformative. If Earth must look away, Mars will not. On October 3rd, 2025, the red planet will have the best seat in the universe. On that date, this unexplainable traveler makes its closest approach to Mars, a rendezvous that could redefine everything humanity believes about interstellar visitors. For scientists, it represents the single most valuable moment in the entire Threeey Atlas investigation. A chance to see the impossible from a new vantage point, free from the sun's blinding interference. NASA's Mars Reconnaissance Orbiter has been quietly reprogrammed for this very purpose. Its high-rise camera, an optical marvel capable of resolving surface structures as small as 30 kilometers per pixel, will aim squarely at the approaching visitor. That resolution won't show intricate textures or written markings, but it may expose shape, geometry, and luminosity patterns that ground-based telescopes could only guess at. Every byte of data will matter. What the world wants to know is simple yet staggering. Does Threeey Atlas shine by its own power, or does it merely twist sunlight in ways no one understands? If it produces energy internally, humanity will be staring at a phenomenon beyond natural law. If it only reflects light, it must be doing so with physics that border on the miraculous. Either outcome rewrites textbooks. Never before has a confirmed interstellar object been photographed from the surface, or the orbit, of another planet. Until now, every image of Oumuamua, 2I Borisov, and the early frames of Atlas itself came from Earth's domain. Telescopes, satellites, observatories orbiting our home world. For the first time, humanity will watch a cosmic visitor through alien skies. This new perspective could reveal structural details hidden by distance, by atmospheric distortion, and by the narrow viewing angles of Earth's instruments. Scientists expect multiple spacecraft, from NASA, ESA, and possibly China's Tianwen network, to contribute simultaneous readings, forming a three-dimensional portrait of the most enigmatic traveler ever recorded. The urgency is absolute. Threeey Atlas is not bound to our star. It will soon slingshot away back into the interstellar dark, perhaps never to return in any era of human civilization. Local comets give us centuries to study. This one offers a single encounter. Miss it and the opportunity vanishes forever. Every transmission, every photograph, every spectral line captured during the Mars flyby may become the only direct evidence humanity will ever hold of what this object truly is. An alien mechanism, or an astonishing natural outlier born from physics we barely grasp. The coming months will decide which version of reality survives. Either we witness the universe performing miracles of nature no one can yet explain, or we confirm the first technological artifact from beyond our sun. In both cases, the story of Threeey Atlas becomes the story of us, a species standing on the edge of knowledge, watching the impossible drift by and realizing that discovery sometimes looks back. And somewhere between Mars and the sun, hidden in the blaze, the answers wait.